Here we're going to look at the first 6 practice problems for topic 90, properties of exponents and radicals. So the triad examples, they're telling us or asking us how can you rewrite this expression using the properties of exponents. All right, so example 1, what I'm going to do or look to do is I'm going to take this 1/2 and distribute that in to each of my exponents. So I would have 3 to the 1 times 1/2 over 32 to the 2/5 times 1/2. All right, I am going to cut out some work here just for the sake of space and time, but you'll be able to see quite easily what I'm doing. So the numerator, 3 to the 1 times 1/2, that's just going to become 3 to the 1/2 power. And my denominator, I have 32. I'm going to multiply the 2/5 times 1/2. I'm not going to show all the work here, but you would get 2 over 10, which reduces to 1/5. Okay, so we're unsure where that comes from. You're multiplying those fractions. The numerator, 3 to the 1/2, you can't really do anything else with that. My bases are different, so the 3 and the 32 cannot be combined. So I'm just going to rewrite this as the square root of 3 over the 5th root of 32. All right, I don't want fractional exponents in my final answer. I cannot take the square root of 3, so I'm going to leave that alone. But 32 is a perfect 5th root, so the 5th root of 32 is 2. My numerator and denominator have nothing in common. They're unlike terms, so I would stop there. It'll take some getting used to, but you'll start to just apply the properties and you kind of figure it out as you go. Sometimes you don't always do the perfect step first, but as long as you're applying the properties appropriately and correctly, you'll eventually get to the answer. All right, example 2. Right now, I cannot combine what's on the outside here with what's on the inside because I do have this fractional exponent. So what I need to do is take that 2/3 and distribute it in. Remember that a has a 1, so that 2/3 will get distributed. So I have 2a to the 1/3. 1 times 2/3 would be 2/3, and 1/2 times 2/3. So this is going to be 2 over 6, which reduces to 1/3. Okay. So again, if you're unsure of that, just work it out either by hand or on a calculator. But 1/2 times 2/3 will give you 2/6, which reduces to 1/3. From here, I'm going to combine my a values. So I have 2a. If you're multiplying the bases, you add the exponents. So 1/3 plus 2/3. The b term I can't do anything with, so I'll leave alone. So we have 2. 1/3 plus 2/3 is 3/3. 3 over 3 reduces to 1, so we'll leave that alone. And then we have b to the 1/3. No fractional exponents, so we're going to rewrite that as the cube root of b. Keep in mind things like this 1/3 only applies to the b. Okay, so be careful kind of determining where these fractions or these exponents apply. All right, be very careful with that. In number 3, I don't have any powers being raised to a power, so there's nothing like outside of here or here. So I can start to combine these. So I'm going to do 3 times 4 times x to the 1/2 times x to the 2/3. 3 times 4 is quite easy. That would be 12. The bases of x are being multiplied, so 1/2 plus 2/3. So there's unlike terms here, or sorry, unlike denominators. So we need like denominators. So if I add these up, I get 7/6. So this would be x to the 7/6 power. Again, no fractional exponents, so rewrite this as 12 to the 6th root of x to the 7th. I want to note that the index is less than the number on the inside, so that means I need to split this up. So 6th root of x to the 6th and the 6th root of x to the 1st. I want these numbers to be divisible, which they are. So this would be 12x times the 6th root of x. And that would be my final answer here. All right, do be careful with when you stop. Make sure that the index is, the index has to be greater than the number on the inside. So if the index is less than, like in this case, 6 is less than 7, then you would need to simplify that. All right, number 4, we have 2b to the 1/2 power, 3b to the 1/2, c to the 1/3 raised to the 2nd power. This is a combination of what's going on in numbers 2 and 3. So this 2 needs to get distributed first. So 2b to the 1/2, 3 squared, b to the 1/2 times 2, c to the 1/3 times 2. So 2b to the 1/2, 3 squared is just 9, that's easy. B to the 1/2 times 2, that's going to be b to the 1st, and then we get c to the 2/3 power. All right, I'm going to rewrite this with like terms next to each other just to save some confusion or avoid some confusion. 2 times 9 is 18. B to the 1/2 times b to the 1st, we're going to add those, so that's going to be 1/2 plus 1. C to the 2/3, we cannot do anything with. So 18, b to the 3/2, c to the 2/3. No fractional exponents, so 18 square root of b cubed, cube root of c squared. The b value, notice that the index is less than the number inside, so we need to split this up into the square root of b squared, square root of b to the 1st. So finally, we get 18b square root of b cube root of c squared. You could skip a lot of those steps. Again, I'm trying to show as much work as I can so you see the methods and the rules and everything that's going on kind of behind the scenes. So just make sure we're on the same page with that. But know that here there's 1, 2, 3, 4, 5, 6, 7, 8 steps here. You would not need to show all 8 steps. There are a few of those steps you could eliminate. All right, let's continue on to number 5. My first thing before I even do anything else, I'm going to change this. I don't like this written out horizontally, so I'm going to write this vertically. I'm going to put the division as a denominator. All right, everything has an x value, so that's a good sign that my final term should just have 1x. Everything is going to be able to be combined. So I'm going to start by adding these two because the bases are being multiplied. So 1/2 plus 5/12. Let's save some space and do this on the side. So this would be 6/12 plus 5/12. That's 11/12. So x to the 11 over 12 raised to the 4th power over x to the 2/3. So these two being added up got us that 11 over 12. I'll then take that 4 and distribute it in. So those are going to be multiplied. So that gives me x to the 44. So we're going to do 4 times 11 over 12, which is going to be 44 over 12, but we can reduce that to 11 over 3. And all of that will be x over 2/3. Okay, so let's just keep track of these with colors. This piece here is how we got that. And that was distributing this here. All right, and then finally, we have division. So it's x divided by x, which means we're going to subtract the exponents. I'll show that step down here. So 11 minus 2 would be 9. 9 over 3 is 3. So we get x cubed. All right, this is a really good example that shows the product property, the powers to powers property, and the quotient property all in one example. So pretty good example to practice those. Number 6, I would look inside the inside the parentheses to see if I can reduce anything. 16 over 81 does not reduce, and there's nothing I can do with the c and the d values. So this 1/2 needs to be distributed. This one's actually easier than it looks to start, but we'll write it all out. So 81 to the 1/2, d to the 18 times 1/2 power. 16 to the 1/2, change that to the square root of 16, which we know. That's going to be c to the 7th. The square root of 81, d to the 9th. Square root of 16 we know is 4. There's nothing to do with the c value. The square root of 81 is 9. There's nothing to do with the d value. And that's it. Can't reduce that, can't simplify anything further. All right, so these are good examples of the properties of exponents. Just go through them, kind of follow the steps. Know that there's not always one route that you can take. Think of it as like walking to a store or a friend's house. There's different routes you can take. You're just looking to get to the same destination. Good luck with those.